Hello everyone. So today we are going to understand Leetcode problem number 762. It's a prime number of set bits in binary representation. Means primary number of set bits in binary representation. Okay. So have you ever solved a problem and then realize you misunderstood one single line? That's exactly what happens with the Leetcode 762. Most people think we are checking whether the number of itself is a prime number, right? Wrong. We are checking whether the count of 1s binary is prime. Binary is prime. Let's suppose if you want to say, we'll say count of 1s in binary is prime. So we should understand the question first, right? So basically the most people will check whether the number is itself is a prime or not, right? But no, we should not check like that. We should check that the count of 1s in binary is prime or not. Okay, and once that clicks, the entire problem becomes simple. So today I'll break down this problem in very simple steps, so you by the end of this video the problem feels like very trivial. And so let's start here. Very first, we have given two string, we have given as two integer we have given, that is left and right, we can say, right? So two integers we have given, left and right, and we must take what every number between left and right is inclusive. So let's suppose there is some points we have given here on this number, right? If this is left and this is right, so if it is at 6 and if it is at 10, okay, means from 6 to 10 there will be 5, 7, 8, 9, 10, like that we will have, right? So you have to take every number between left and right inclusive. Means if we have 7, if we have 8, and if we have 9, so you have to take all these number, right? Then you have to convert it to binary. Very first step is you have to take every number between the left and right, and second you have to convert into the binary, right? Once you will convert into binary, right? If you see here, we are converting these numbers into binary, right? Once you convert this into binary, now you have to check, or you can say in the third step you should count how many 1s it has, right? Once this is done, if you see here, it is saying 2 sets bits is 2 is prime. Now 3 set bits are 3 is prime. 1 set bit 1 is not prime. Like that you have to check, right? In the first step, if that count is a prime, if that is a prime number, let's suppose, it means you have to do increment the answer. Okay, so here is prime, here is prime, here is prime, and here is prime. How many times prime? 4 times. Means 4 times you are getting the prime number, right? Set bits, and so the output is coming this one. So you have to return, like very first you have to take every number between the left and right which is inclusive, then you have to convert it into binary, then you have to count how many 1s it has, and then if that count is a prime number, then you have to increment our answer, and finally you will return the total count as a answer. This is what the question is saying. Now important thing we have to understand is, let's suppose we are not checking if the number is prime or not. We are not checking if the number of set bits is prime or not. So that's a distinction is everything, right? So I hope you understand this approach. And for background, you know that the prime number always start from 2, right? And if we'll talk about prime number less than 20, right, what are the prime numbers are there? We can say 2, 3, 5, 7, 11, 13, 17, and 19. So these are the prime numbers, guys. So if you see here, 2, 3, 2, 2, these are came, right? So it became the prime number. So total 4 times it came, so the answer is 4 here. That's the entire logic we have here, right? Let me show you the code so you will understand clearly. So if you see here, we have a prime mask, right? And so this is just a iteration, right? We loop. Let's suppose we have to start from left to right, right? So for each iteration we are doing from left and we are going till the right. Okay, so for each number in the very simple steps is you have to count set bits, you know the set bits, right? Then in step 2 you have to check if that count is prime, right? And then we increment the answer, your result. Okay, this is what we have to do. So there is no sliding window, no 2 pointers, no recursion, just a clean iteration, guys. And one thing you should understand that there is only, if you want to, let's suppose, count how to count set bits, right? If you're thinking how to count the set bits, this is the main thing here, right? So there is two options. Option 1 is, this is the best option in Java. You just need to do what? Integer.bitCount, and you need to pass the number, right? So this is a built-in and it's very optimized that we are using here. If you see integer.bitCount, we will pass the I, because the left will start from, let's suppose, 2, 3, 4, like that it will keep moving. So in our course example, 6, 7, 8, 9, and 10. So all bits count will be getting here, right? So bits, once you will get the bits, you just need to check it's a prime or not, right? If it is prime, just increment the count, right? The other approach to check how to count the set bits is, this is a option, it is called Brian Cunningham, if you remember. So this is a Brian algorithm, right? So this is a Brian Cunningham algorithms, right? You can also use either you can use the Java inbuilt functionality, which is optimized. Otherwise, if you are not Java beginner, or if you are good at C++, you can use the Brian Cunningham algorithm, right? Where you will check in the while loop that if while n not equal to 0, right? In that case, you will check n equal to n, and you will do n minus 1, like that, and then you will increment the count plus plus. So you can try that approach also. So each options remove one set bits, right? So this is the thing we should understand, and this is a efficient approach and a good or great interview tricks also. But in Java we will use like this, we will use a bit count unless Java interviewer are not saying or not blocking you. This is what we have, guys. So now here you understand that the constant is up to 10 to the power 6 we have given, right? But the binary representation of 10 to the power 6 has at most 20 bits, let's suppose, right? 20 bits. That means the maximum set bits possible is 20, correct? And so we only need to check if the number between 0 to 20, right? If the number between 0 to 20 are prime, that's a tiny. Instead of checking every prime time every time, right? Instead of checking the prime every time, we can pre-store the prime value in a boolean array, and then it makes the extremely faster the code, and so you can approach that, right? Or let me tell you what I am trying to say. You just need to say that, let's suppose we will not implement like this, but in place of what you need to do, we can say okay, boolean, and you will say the prime equal to new boolean, and you will give the size 21, right? Then you will define all the prime, right? Prime at 2, prime at 3, like that. You have to keep going till prime equal to 19, prime 19 equal to true, and then you will just need to pass the same thing that you are doing here, right? You will pass, and once you will pass this, right, you will get the bit counts. So here you just need to write that if prime is a bits, right? If this is a prime, you will say okay, increase the count plus plus, like that. You have to keep going, and finally we'll return the count. Okay, let me show you how. So as I told you, very first we will define the boolean as a size 21, then all the prime should be true. Once this is done, we'll take a count equal to 0. We'll start the left from left to right, and we'll get the bits using the integer.bit counts. And if prime add bit is true, increase the count plus plus and return the count. So this will take you the time complexity of n and a space of O of n, O of 1, because this is a constant that we know that, right? This is very simple approach that you can use in the interview, right? So it's all depends on the constraint, right? The number is going to goes to the up to 10 to the power 6. So the binary representation have 10 to the power 6 has almost 20 bits, guys, right? And so we thought to take it here as a constant space. So because we know that the maximum set bits possible is 20 only, and so we only need to check if the number is between 0 to 20, right? And that we will keep checking, and once we will keep checking, we'll just increase the count plus plus. So instead of checking the prime every time, right, we have only pre-stored this prime value in the boolean array, and it makes very faster than the previous code. So that's all I have in this video, guys. In case you are good to go, right, you can write in the comment box that you understood. Support ExpertFunda by liking, subscribing and sharing this video. And in case you are seeking with DSA or Java, you can join our online classes. Thank you for watching this video. I'll see you in the next one.